so I'm just going to leap into this. Try to spend just a little bit of time on the background. If you go to the next slide, that'll be the overview, Julia. Thank you. We'll do a quick introduction to who the 309 SWEG is, why we decided to change from the processes we were using to more of an agile approach. I will go quickly through what the Warthog does, and our old waterfall process and our new agile approach, and the challenges and the lessons learned that we have, which I'd like to spend a considerable time on the last half, if I could. So next slide. This is where we fit. If you're an Air Force person, this will mean something to you. If you're not, you will have no idea what we're talking about. But for those of you who are interested, there were 3 software groups scattered about the country. There was Hill Air Force Base in Utah, where I am at, Tinker Air Force Base in Oklahoma, and Robbins in Georgia. And all 3 of us now have combined under one software directorate so that we can share lessons learned. And it's becoming interesting. We are a very large organization now, and we're starting to act like it, but we have a commitment towards doing software, high quality software, in the right way. So I thought that'd be an interesting background. Next slide. Here's the A-10 team at the height of what we were doing. We had just made the transition to Agile about a year earlier than this picture. And not long after this picture, the powers that be decided they were going to stand down the A-10 by 2028, and we're now about half that size due to funding cuts. But we're still producing software, and we will be producing software and adding features to the A-10 until they shut the doors on us. So next slide. So this was a slide that was added. By the way, this whole slide set was created for somebody, another audience. However, it was so well received, and it went through public affairs already, so I didn't redo it. But this was our group director, our project director's slide on how can we get software to our warfighters earlier, with what they need, when they need it, and with high quality. And he said in order to do it, we had to take this leap of faith like Indy does in this movie. So we decided to take a leap of faith. And I remember I was on the program as the software coach, and the project director came to me and said, "We're going to rip the Band-Aid off and we're just going to do it." And I said, wait, we haven't finished the pilot program yet. We're still haven't done a complete release with the pilot. And he said, "No, we know what we need to know." And so he ripped the Band-Aid off, and it worked, strangely enough. Then COVID happened and we all went home. But next slide. We did it from home. Here's a background on the A-10. First flight was 1972. Then the last flight's going to be somewhere in 2028, probably, unless things change. We're actually working on the most recent version of the A-10s, the A-10C, which has a lot of software in it. Earlier versions of the A-10 had little to no software in them, and I remember in 1998, I started the mission planning process program at Hill Air Force Base, doing something called TSP back in the day. And at that time, there were only a couple of we call line replaceable unit computers on the A-10. And even then, the pilots were a little upset about it. I just want to go over there and blow that thing up. Why do I need all this computer stuff? Now it's integrated in everything they do. And the pilots are younger and they understand software and they're excited about it. The big thing on this aircraft that you've all heard of is the 30mm Avenger cannon. You don't want to get hit by one of those. Those bullets are that big. So, and it's amazing. Next slide. We are in charge of the complete operational flight program. So this is everything that the aircraft needs to load stores, weapons, to activate those weapons, to communicate with them, to get the feedback that they need from other aircraft and from ground systems, to read data from the mission planning system and to post data to the system for post deployment review, all sorts of stuff. Everything that you can think of to do that is on this aircraft. That's the operational flight program. We also have a unit that handles the loading, memory loading and verifying of all of those computers, and the mission planning software as well. So in waterfall terminology, we released suites, and we did suites, suite planning, and we would sit down and say, we believe this is where we're going to start and where we're going to end. We'll be over here somewhere, and we'll have this many new capabilities, and it will take about this long. And it went through a very standard waterfall requirements, design, implementation, and test type of approach. We called those suites as they went out the door. And a suite took about 2 to 3 years to develop, and we usually had a couple of them going simultaneously, so that as soon as the requirements for one were done and the design started, they'd start on the requirements for the next one, so that it kind of tried to hit the field once a year. Very rarely met that goal, but we had candidates for change that would go into each of the operational flight programs and go out the door. When we moved to Agile, we decided to have the customer-facing work item be an epic. Epics are the terminology we use, and it's for everything from a new capability, a change capability, or a defect correction are all epics. And those are all racked and stacked in the same backlog. So next slide, we'll talk about this a little bit more. One of our so just quick overview. We have the CDU, the KICU, we call it, the central computer. It's mostly in C and C++. That was converted from Ada, so that's fun to work with. We have the fire control, which is in Ada, C, and assembly. The navigation, which is Ada, C++, and we have a CPU, what they call it, the CPU, Central Processing Unit. That's in Jovial and C, and that's actually the IEPU, we call it. And as you can see, we have the cockpit displays there. These computers run those displays. They run the head-up display, but they also communicate with the weapons real time. They communicate with some weapons while they're in flight. It's a complicated thing. Next slide. So it's a system of systems, really. Some of the things that we have been doing in recent fielding releases, we've put new bombs on the thing. Our proudest moment was that we now in the A-10 can do something called small diameter bombs in a very large quantity all at once and drop them in all sorts of configurations. We now are the best at dropping those, and we're last time I checked, we were at 97% accuracy on them, which is the highest that anybody had ever been. New rockets, we've got brand new radios, which are a challenge because it's not just our software, it's their software that we have to worry about. We've got new nav technology, how to apply that navigation technology. We have menu system updates as we put all these weapons on the aircraft and provide different methodologies for using them. We have pilot situational awareness updates on their displays and on the HUD. Cybersecurity is a big deal these days, and we spend a lot of time making sure that our code is secure. We actually have pipelines to make sure those are secure. We have updates to messaging and how we do the messaging through digital means, and we spend some time doing bug fixes, mission planning enhancements, and the interface to the digital airframe. So this is all part of a standard update. Next slide. In order to program and test it, we have a couple of different methodologies for using. I'm showing one of them here. This is what we call our high fidelity test stand. It mimics the actual aircraft. As you can see, it doesn't look like the aircraft, but it has all the same line replaceable unit computers. It has some real weapon systems that we attach to it, some real targeting pods that we attach to it. It also has a lot of simulated or emulated devices that we can attach to it. This is really a system integration effort when we do the lab, because there's a lot of different parts that have to play together to make this work. And we try to mock it up as well as we can so the pilots can come in and fly it while it's still on the ground, and make sure that we did what they think was going to deliver value. Next slide. We also took the wings off of our regular Warthog, pulled it into the lab, and have it set up with simulated inputs so that we can see real time, hey, is this going to work in the cockpit? We've got this new weapon that's going to fit on the body of the plane or fit on a station. How's it going to fit? Are these things going to work? It's been interesting to see this as well. And this is kind of a very hands-on, very down and dirty kind of a test equipment that actually gives us a lot of very valuable feedback on how other systems actually interface with the A-10. Next slide. We also have a completely emulated environment that they can run at their desks, where all of the computers are emulated and the inputs are simulated or stimulated, and they can actually write their code, run it here, and get a 80%, sometimes 90% solution there before they take it to the test stand, which has really sped things up. In the past few years, we have begun automating the testing on those. So they have Python-based testing that they can run very quickly, and a lot of built-in methods that they can go grab and say, hey, I need to initialize this system and look at these values, and they can automate that. So that would be like a user interface or a pilot vehicle interface automation that we call it. Does it display the things as it's supposed to? Do the buttons react the way they're supposed to? Do the menus react the way they're supposed to? Kind of thing. Next slide. So pre-waterfall process, we would meet at something called the ASRC, which stands for Avionics System Requirements Council, I believe is what it stands for. And we would gather up a list of candidates for change from all the pilots and from folks that could see what was coming down the pike. And we would have 3 rounds of candidate review meetings as we looked at each of those things, and we do preliminary designs, usually in PowerPoint kind of slides of how they would play with each other, what they would do, what they would look like. After the first configuration review meeting, we would downsize it from maybe a 200% list down to 150%, do a little bit more research on it, and then come back into a second round. And the third round was going to be the final cutoff line, where these are the things that are actually going in. Design documentation, such as system design change requests is what we called it. And that would change the design documents, like the system requirements document or the software design document with the new changes. They had to be approved. They had to be peer reviewed. So as you can see, up front, we did a lot of work and no lines of code were written during this time. So if you look at the value stream mapping of this old process, it worked extremely well. They were able to get the things out the door that they asked for. The problem was that it just wasn't very responsive. And where the value comes, of course, is in the software. And the software wasn't even started until the requirements were defined and the designs were completed. And so we were a kind of a stovepiped organization where there was a system requirements team, and then there was a software development team, and there was a test team. And we would often gather together among people who were going to be working on the same kinds of candidates to form what they called candidate teams. It wasn't well defined. There were people on the teams that were kind of partially related to the candidate and not fully related to the candidate. There were people that were sat on 3 or 4 candidate teams because they were working pieces of each. It helped. It really did help, but it wasn't very efficient. One of the problems we have with any kind of system like this, where you define requirements up front and get them reviewed and get a cutoff and say that's what you're going to do, is it's not very responsive to change. So about 2 years before we would release that suite to the field to go on the actual A-10s, we'd lock that list down And if they wanted a change to the candidate, or if they wanted to put new candidates in, we had to go back through a process that we called the engineering change proposal process and review it and see how it was going to impact cost and schedule. And if it was acceptable, we would insert it into the plan. Almost always caused it to slip. This 4.6 years thing that you're seeing here, that's based on some data analysis I did. And you'll see on the next slide a real life example of that. So next slide. So this was an update that we actually had planned on doing before we moved to Agile. And as you can see, it's very, very precisely laid out. We start with requirements early in the process. Then we go into a design review phase. And once we get that critical design review done, then we go into software development, which includes updating everything. It includes updating the software. It includes updating the test procedures. It includes updating the actual document, finalizing the actual documentation. And I kind of did an analysis there of when does the first piece of software get on an aircraft so someone can flight test it. And it was about 32 months into the process before that actually happened. It was 2 years before we saw the first software go to a pilot to sit down in our test stand and try to fly it. It took 9 months from ASRC to our third CRM, and that's before software design started, before we even had the list of requirements to get started. Now, honestly, we did overlap these OFP releases. So from a user perspective, it looked like it was moving a little faster, but the resources required to do it were the same. So that if there were problems from the one that just went off into design, the requirements problems from the one that just went off into design, if I had worked on it, I had to pause what I was doing on the current OFP that we're trying to release, go to the prior one and try to fix that problem. Also, if there were in the process of fielding and flight tests found an issue, that issue had to be changed not only in the released version, but in the one that was in work and in the one that was just about to come out as well. So it was kind of a configuration management nightmare as we were doing it. So if you were a pilot and you proposed something at ASRC that you thought was a really good idea and really needed to be done, and you had 5 years left before your time was up, you may never see it on an actual aircraft. That's the sad news about that. So next slide. So what we decided to do was take an approach of a team of teams. We looked at all sorts of different approaches. We looked at Scrum of Scrums. We looked at Scrum at Scale. The popular one going around in the Department of Defense at the time was Scaled Agile Framework. And so we kind of looked at how to do that in terms of a Scaled Agile Framework. And one of the things that was suggested from SAFE was that we create, from these stovepiped groups, we create an Agile team. And we decided to do that. We decided to cross-cut that through the system. I'm going to skip a slide down to one more slide, Julia, and I'll kind of show this graphically on the next slide. So this is how we were arranged. And then if you click the next button, it will show you how we just click. Yep, there we go. And there's how the Agile teams were actually formed. So we started to group people together that had the skills to get an entire candidate, or what we now called an epic, through the pipeline and into the software baseline. Of course, we followed a Scrum process. So if you click next, you'll see we added product owners, and one more time, and Scrum Masters. Now the product owners were, this is a really time-consuming and difficult job, being a product owner for an OFP, because you have to understand what the pilots want, and you have to be able to translate that into what the team can do. Scrum Masters also have a difficult job, but we were not able to multiply product owners. We don't have multiple product owner, or one product owner working for multiple teams. It's one-to-one. But Scrum Masters, we were able to do that with, where we were able to get Scrum Masters to handle a couple of teams sometimes to get that to work. So back up to the previous slide. You'll have to deconstruct this slide, I think. Yeah, there we go. So how it worked is the pilots would we get a big backlog. They would rank the epics based upon kind of a weighted shortest job first type of approach, where they would look at the importance of what was being done, the value it would produce, and the difficulty with which it was estimated that it would take in order to do that, and kind of ranked them in that order. We also reviewed each of the, as engineers, we would review each of these epics and look at any type of blockage conditions. For example, hey, this product would be great to integrate. The problem is it doesn't exist yet. Or we don't have the ability to test for it. There's no test stand for it, or something like that. So we would go through the whole backlog. There are somewhere around 700 epics in the backlog right now. We typically only deal with the first 100 or so in any one update. We created an architect team whose job was to groom these epics with the pilots and make sure that anything that was in the backlog, especially the stuff that was near the top, was well understood and the path forward was clear, not blocked, and get it ready for Scrum teams to, this is a pull system where they would pull the epic from the top down. In addition to that, we took some of the meetings that we were typically doing and we just repurposed them for use in an agile environment. So we had something called a video teleconference meeting. It's really, there's no real video involved anymore. It's really just screen sharing, but we were able to get real-time feedback from pilots on a weekly basis. We meet with the program office about 3 times a week as well. And then 3 times a year, we have the pilots come to our location at Hill Air Force Base, sit down with us, go through all the epics that we've produced so far, and fly them and give us feedback on the value. So SAFE recommends 4 times a year, and we actually tried that, honestly. It was too fast for the pilots. They could not keep up with it. So we had to back off 1 PI. I think now after almost 5 years of doing it, that the pilots know it well enough, we might want to try going faster again, because the more increments you have, the less any perturbation affects you. One of the things that was really cool is we were working on 1 release at a time instead of multiple releases at a time, which has really kind of helped us out. There's a lot more flexibility. Epics are not locked in a waterfall. We tried to build the process like it says in the Agile Manifesto, so that even late breaking requirements can be implemented without impacting our processes or our ability to deliver on a cadence. We meet with what we call the integrated test team. That's not us, that's the pilots doing operational testing, developmental testing, and the system program office as well, to re-rank and update those on a weekly basis. And then we just pull the epic straight from the ranked backlog and begin working them with approval from this team. And we meet with them so often that that approval is really easy and fast to get. Next slide. Yeah, we already did this, so we can skip through that. Next one. Okay, so those of you that know SAFE, let's say, hey, that looks a little bit familiar from the old way. We took essential SAFE. Anything higher than essential was really difficult for us to implement, because it would have been, we really didn't have a single point of contact to act as kind of the overall group lead. So we just did it in this manner, which is our customers sit on the team that helps us review this in the program management block. We have folks on the program management block. There's that architect team on the left-hand side at the top in the system layer I was talking about. And all of these folks are in charge of grooming that program backlog. The teams, the agile teams below, begin pulling them out of the program backlog into their product backlogs, decomposing them into, we actually use both features and stories with acceptance criteria and specific definitions of done for each work item. We do 3 program increments a year. The third one, as you can see, that starts in August, goes clear to the end of the year, so it has a couple more sprints in it. That's to kind of even out the calendar, and also because at the end of the year, people aren't in office as much. So that gives us a few more weeks to compensate for that. We used to have the pilot evaluation and our planning session right before the PIP, right before the program increments started. So if you've taken Scaled Agile Framework, they recommend that the last sprint of your PI, of your program increment, be that, what is it? Inspection and planning sprint. We moved it back a couple, because what we were finding is pilots were pointing out some things that were fairly easy to fix. And we're getting ready to flight test it. It would be wonderful to have those minor things repaired before they went out the door. More major stuff that would have taken longer ends up in the backlog, and they gets worked in the next program increment. One of the things that we decided early on after going through one cycle of this for a year is that we really need to make it so that every single release at every program increment is possibly fieldable, so that any one of these could go out into the field. Now, the field has cried uncle and said, please, only once a year, that's all we can handle. But the pilots have said otherwise, and recently we did a release where 2 of the program increments actually went out sequentially from each other because they really felt like they needed in the field some of the capabilities that we were producing in those program increments. So they are all potentially fieldable. Now, one thing that you can see is kind of missing from this, and that is a test team. We don't have a test team anymore. We don't have kind of safety of flight test teams or regression test teams or integration test teams. We actually made those epics, we made those epics, and we have the teams take those on themselves. So every PI, a different team, gets assigned to do safety of flight testing. Integration testing we've actually built into our pipelines that we have, and system testing as well as required of the teams. We also do regression testing in terms of both ad hoc testing and rerunning the automated tests that we do for each of the epics as they go through. We have a very old system, and those of you that have older systems should probably be aware that automation in older systems is hard. Integration is difficult, and continuous integration is even more difficult when you're dealing with C, C++, and ADA type languages. And so we had a very creative software architect who came up with a process using source control and Git that approximates what you would do typically in a continuous integration environment. It does not allow us to integrate directly into the trunk like you would on most continuous integration programs, but it does provide the same benefits without the dangers that you have on these kinds of systems of messing up your APIs or your interface control documentation and breaking every other epic besides yours. So it's been kind of wonderful to see them actually implement it and get things out very, very quickly. So instead of an idea taking 4.5 years to get out the door from the time you came up with it, you could literally propose something at one of these program increment planning sessions as a pilot and see it implemented and fly it in 4 months or less. Next slide. In order to make this happen, we have a lot of communication. One of the selling points I had to the teams as we were talking about this is, hey, the number of meetings that you're going to have is going to reduce. That's true, but the frequency of meetings actually increased. Daily, at least in the middle of the week, all of the Scrum teams, or the Agile teams, we're calling them now because some of them are doing Kanban, do daily stand-ups. They all do that. We have what we call a product owner Scrum Master coordination meeting. This is the Scrum Master sync or product owner sync that you see out of the Scrum of Scrums or product owner sync that you see out of SAFe and out of Scrum of Scrums. We did this once a week for a while, and we found out that we actually needed it more. So we actually do it Tuesday, Wednesday, and Thursday. With different audiences for some of them. There was one that we coordinate with all of our external stakeholders that actually produce products for us once a week as well. We also meet, as I mentioned earlier, with our integrated test team, with the entire program office. We show epic designs. We show epic implementations. We record video of pilots either flying or our engineers either flying on the desktop simulation or in the actual test stand, and get that video approved for release and out to them so that they can watch it and give feedback as quickly as often as possible. 3 times a year we actually bring them in, and we actually found that wasn't sufficient. 3 times a year was not sufficient to be as responsive as we needed to be. So we have started what we call mini pilot evals now, which is 1 pilot or 2 pilots are available, and they will drop in and give us feedback real time as we go. I really think that's what makes us agile, is this ability to get not only quick turnarounds of software, but to get that rapid feedback from the pilots as to whether or not we're going in the right direction so that we don't go off in the wrong directions. So one of the things that happened as we split up our stovepipes into these cross-cut agile teams is the individuals are now separate from each other on different teams. And when they were stovepiped, one of the things that was an advantage was they were able to do a lot of cross communication and learning from folks that are doing the similar or even the exact same things. Over the past several years, we've evolved into this situation where once every couple of weeks we have these workshops for people who do development, or people who are product owners and Scrum Masters, or people who are test engineers or systems engineers, or who do automated testing, to get together and share information and lessons learned and best practices across, so that number one, they know who everybody is and they know who the experts are. And if they run into a problem, they know who to go talk to, even if they're on another team. But number two, that they can actually learn these lessons and begin implementing them, and we can be much more consistent on how things are implemented across the board, and learn and grow from each other. Next slide. Okay, one thing that I didn't say that I probably should have put in those slides. We had a suite of processes for A-10 when we were waterfall. There were hundreds of pages involved. This is a fallout of a little overexuberance in implementing CMMI, in my opinion. When we went agile, most of that became extinct. It was no longer as usable. Instead of rewriting them, what we decided to do was create a wiki and begin documenting those things that we needed to do and know. It started off with maybe a half a dozen files in the wiki telling you, what's a program increment planning session, how do you do Scrum, what's a retrospective, things like that. Very, very high level stuff. And it is now over 750 files, mostly written by the people who do the work and used as reference when they go to do something specific, like, hey, this is the first time I've done a build of this particular subsystem. And I need some help on that. And it's in the wiki. And it's been updated by the folks that actually do the work. So that when the tools change, or that when they find new information, it gets updated and everybody gets that information. I think that's been incredibly helpful and useful as well. As I said earlier on this slide, we did our own version of CI/CD. What we did the out-of-the-box thinking. We have an integration branch. So we have the main production branch, right? That was the last release. We have this integration branch down here where everybody is just a copy of the production branch. And then each epic has their own stream as well, their own branch as well. And that they come off that. They do their development in that branch. When someone is done, they do the pull request and get their code merged up into the integration branch. Now that includes them having to do an integration test by pulling down any changes that will have been made since then. First person in, no changes. So they just test the integration and then they do a pull request from the integration branch to grab their stuff and merge it in. All other teams are instantly notified that these changes have been made. They pull those changes down into the branches they're developing on, deconflict as they go, and then pull it back up later. It's not as smooth or as fast as a CI/CD environment would typically be, but with these older environments and kind of brittle software that we're dealing with, it's become extremely useful. It was very out of the box thinking, and it has helped us to be able to integrate as we go without running into the same kinds of bottlenecks that we would in the old waterfall process where everybody's waiting to the end to integrate. We have to do hardware in the loop testing. I don't think that's ever going to go away because we have real hardware out there that we have to interface with. And we have real feedback from other folks' software and other folks' hardware that we have to deal with. Simulations and emulations can only go so far. And so even with automated testing, we end up automatically testing on the test stand with hardware in the loop. We've been able to do quite a bit with that. We have one test that we used to run for safety of flight that had to test every kind of mask zone that you would have for the laser and the targeting pod, laser targeting pod. And it took about 12 hours to test every single one of them by hand. We've got that down to about 2 or 3 hours now using automated testing. It still takes time. I don't think it'll ever be done. One of the problems that we have with this kind of software and this kind of hardware is it's unique, and there aren't a lot of commercial off-the-shelf products that can integrate with it and work easily. So we ended up creating our own system from some COTS and creating a team that does nothing but maintains that for us, and it has proven to be very, very effective. One of the things that we had to train both the system program office and the pilots on is this idea of cadence versus schedules. In the old days, you would create a schedule, you would figure out how long it would take, they would fund you for that amount of time, you would do earned value against that schedule, and you would see if you were on schedule or not. And at a cadence-based system, you just release every program increment. And the pilots have gotten used to that now. I wish I could say that we never slipped a cadence. I'm teasing our management right now because they decided, pilots said, hey, listen, if we really need these things integrated before we go out. And so they said, okay, well, it's only going to take a couple of weeks. We can do that. Well, everybody out there knows what happens when you give the customer, when you say we're going to take a couple of weeks and we're going to put some more stuff in the software before we release it, right? It's, well, while you have the hood up, can you check this too? And it is already delayed more than 2 sprints. And I told them if it goes to the end of the PI, I'm going to say, I told you so. You should have just released the PI and put that in the backlog, worked it in priority order. But anyway, you always have to coach. The support organizations, they have to flight test as they go. They have to flight test every 4 months. If they don't, and this happened once, they can miss a defect that could have gotten fixed earlier, or just an implementation issue that they would have preferred be done better or elsewhere or in a different way. And they can miss that if they don't do this. We have limited resources. We don't want to waste their time. And if you're doing things on a cadence, they can plan for that and they can say, yes, we can support that and we can fly it. If they miss one, they happened. We actually had one missed. They missed an implementation issue that they could not find in ground testing, that they could only find when actually doing the actual testing in the aircraft. And we ended up having to fix it later in a kind of a quick turnaround fix. And that was unfortunate. And they raised their hand and said, that's our bad. There are, if you work in a very large organization that has a lot of tendrils to it, like any type of government organization does, there are downstream, we call downstream impacts to things like trainers and tech orders and other things that require, that they still think of in terms of waterfall type stuff. We had a very creative team that was handling tech orders, and they came up with a methodology of updating the TOs real time by which epics go into the baseline. And so they have a TO person that sits on each of the Agile teams and watches as things progress and they begin working on it. And if they don't make it, they abandon that particular branch or at least pause it until the next PI. And they only implement those things that are actually integrated. And they've been able to make it work amazingly well. The TOs are done within weeks of the, like 2 or 3 weeks of the software being completed. And that's amazing. Trainers were still working to get that turnaround a little less scary for them because they're used to a yearly drop of basically system change documents. One of the things we did, and we decided on early, if you want a lesson learned, is we used to do, here's the system design change, and then you implement to that system design change. And if you find out there's a problem in implementation, you have to write a change request to the system design and get it changed as well. And it was kind of a long process. So this time around, we do an epic description that can be put into the system design update. And we don't finalize that till all the software is complete and everything is known for sure. And so getting them an early copy of the system design change request turned out to be not helpful. So instead, we give them the epic and we give them some of the grooming information that we have with those. And I believe that we have to involve all of our stakeholders, especially those that do developmental testing, operational testing, any type of support to get it out into the field. We have to involve them throughout the entire process. Agile things can change on a dime and they're designed to change on a dime, but if the support organizations don't know that, then they can't provide the help that they need. Am I over yet?
You've got about 5 or 10 minutes or so.
Okay, so
Say 5 minutes, David.
Okay, so let's put up the next slide. I'm almost done. So we did this move to support the warfighters when they needed it. We were watching the warfighters kind of struggle with this idea of it taking several years to get something that they needed next week out. We really, really rely heavily on the warfighter feedback. So I did some data analysis the other day, and honestly, the number of lines of code that are going out the door is about the same as it was in waterfall. But these lines of code are what they need when they need it, and not something that's been delayed for a long time. The focus is on built-in quality, quality as you go, checking quality as you go. We did not abandon peer reviews. We still do peer reviews. We do have static code analysis. We do have cybersecurity built-in type things. We have implemented unit testing in Ada, believe it or not. So unit testing is now a thing in some of these legacy systems. We leverage a lot of automation, automate as much as we can. Unfortunately, we can't do the automate everything from DevOps, but we are pushing in that direction. We want to deliver on cadence. So if some feature doesn't make it in because of the cadence, I'm actually okay with that. And so are the pilots for that matter. We plan for change, and we improved the employee work environment. This is something that we really didn't focus on in the slides, and that is that the overtime for waterfall, especially towards the end where you were getting ready to release, was incredible. It was about 20%, 25% sometimes overtime that folks were working just to get things out the door. Overtime has pretty much gone away since we implemented Agile. Also, like I said, we weren't completely ready to start, but we used an Agile mindset in doing it. And that is that we knew what needed to be accomplished in the short term. We did it. And then when we hit a wall, we refactored. And we just kept doing this until we refined the process well enough now that people are just not finding a whole lot in their retrospectives now in terms of major process changes. We used to find them every single retrospective, but now we're finding just kind of tweaks to the system or brand new things that need to be done. Don't wait, do it now. Don't wait for everything to be perfect. Don't wait for automated testing to be complete. You can do Agile without all of that in place. It's not going to be as easy or as efficient, but you can begin working in that direction. I think the Agile mindset helps with it. And with that, I think my time is up. So I'm going to pause and go ahead and answer questions.
David, I'm going to pose one question from Bob Lee. He said, our office is within walking distance of the Peace Air National Guard base. For air refueling, there's 4 or 5 A-10s parked on the tarmac at any given point. I wonder if they're running your software. I'm guessing the answer is yes.
They are, yeah.
Can you address, David, how prototypes might be handled or any kind of proof of concept? How does that integrate into the life cycle?
So that's really fascinating. During the pilot evaluation, especially, but anytime, we can have several courses of action on implementing any one piece of an epic, right? It could be implemented one way, it could be implemented another. Not necessarily an advantage from an engineering perspective, one way or the other, but maybe from a pilot perspective, there would be. And so they will gen up either, depending upon where they're at in the process, they may gen it up on just slides and say, which one do you want to do? But in the middle of pilot eval, I have watched teams, and at first I thought this was unique. I thought it happened one time. I thought this is fantastic. I'm glad it happened. It's happened many times since. Pilots will come in, they'll fly something, and they say, you know what? That's just awkward. I don't want to have to reach over here and reach over here at the same time, take both of my hands off the HOTAS here. What's going on? Can't we put both of them on the same side? And then another pilot will say, well, that could work, or you could toggle over here, and then they would talk back and forth. And I've watched them come back after lunch and have both of those options already coded in an engineering build prototype, if you will, and have them fly them and have them figure out which one they want. And almost always they will pick a third option that hasn't been done yet, but but it gives them some kind of feedback, and the pilots really love that. They love this idea that it can be done quickly with real-time software. Now, that's not the final version, obviously. That's prototype, and it will have to go through the regular software life cycle to get published, but or to get finalized. But yeah, that happens quite often now.
There's one question that was posted. Tarek says he's been on 2 Navy projects. In both cases, the Scrum Master and the product owner were the same person. I assume you might have some thoughts on that. So,
yeah, I don't think that's necessarily a bad approach. We decided to make them separate for a couple of reasons. In the Air Force, especially in the civilian side of the Air Force, having a lead position, somebody that you can poke and say, could you please answer this question or go show up to this meeting or do whatever, is a desirable thing. And taking the product owner out of actually producing stuff, right? To do that was considered to be less desirable. So they created basically a Scrum Master position / lead engineer position to do that. But I don't think it's necessarily a bad thing to have a combined product owner Scrum Master, especially on a smaller team of like 5, 6 people. It wouldn't be that bad.
So I apologize if this is a whole nother tech talk. I assume it is, but could you maybe just elaborate a little bit on how commitments are made for the A-10 in terms of, so I assume cost, effort, and schedule are probably fixed. You talked about fixed cadence.
Right.
So therefore, the thing that's not fixed is the scope, the features, or the epics. How are those estimated, and how do you know what will be likely to fit into a program increment?
So if I had to talk about improvements in any area, it would be this in design. So we'd create what we call a roadmap. Now, the roadmap is the epics that are to be worked. When an epic is originally created, they give it a job size, which is because of the type of tools we're using, it's a Fibonacci number. It doesn't really need to be, but it is. And it's a guesstimate of the number of sprints that will be required in order to implement this epic. Using that information, teams sit down and discuss it. They go through the requirements of the epic, and then the product owner typically is the one that documents on the roadmap when they plan, which sprint they plan on starting on this epic and which sprint they plan on completing. I do not believe in the 5 years we've been doing this, we have ever done it the way we planned it. The commitment, though, is because we meet with the pilots basically a couple times a week, and they see our progress, and then they come in once every 3 months, 4 months, once every 4 months, and sit down with us and go over this. None of this is a surprise to them. If anything changes, if we find out, I'll give you a real life example. We're dealing with radios, and some of the software in the radios did not, I know this is a shock, but it did not follow the interface control documents. And we were unable, stop laughing, guys. And we were unable to implement the software the way we thought. And it required that the program office create a contract vehicle to get back to the original equipment manufacturer in order to modify that ICD, or at least tell us what the heck the ICD actually was. And during that time, we had to put a pause on that epic. We had to block it and put a pause on that epic and have them work something different, which changed the roadmap, right? And this is not unusual. Stuff like this happens all the time. And in addition to that, we find out the opposite also happens, which is someone will get done with an epic much sooner than they thought they would. And now they've got available time, they can pull a new epic in and begin working on. So we actually deliver, based on my analysis, we actually typically deliver more epics than what we had planned. They're just not the same epics we had planned on doing. Okay. Somebody's asking, while organizations are moving away from Agile Scrum because they find it's not cutting down delivery times, is introducing more meetings and less productivity. Your process seems to have many benefits. Could you talk about the workplace and the workforce benefits you were mentioning in the end? So one of the benefits, I'm not sure everyone on the team would agree with me on that, by the way. We have a couple that really liked the old way of doing things in terms of getting the designs handed to them and just implementing the designs. But the majority of folks find it an easier environment to work in. One of the things, I worked on a very successful project called Expeditionary Fighting Vehicle for the Marine Corps about a decade ago. Ooh, almost 2 decades ago now. And it had such a heavy turnaround and a lot of effort associated with it that we actually went through, I think we ended up with 110 people working the project, and we went through over 220 to get to that 110. It was stressful. I think the stress levels for A-10 have died down considerably. We're seeing people not working weekends to get stuff out the door for the final build. We're seeing people gone by the time they're supposed to go home, and still getting things done and still getting really good software done. And to address the reason that I think is behind some of this, one, if we had decided to do agile teams within the stovepipes, and I've seen this done on something as complicated as an OFP, it makes some sense actually. and we just did system designs. And then the system designs got spit out to the development team. And the development team spun out their stuff, and that got kicked over to the test team, and they ran their tests against it. And each Agile team kind of worked just that piece of the epic. I don't think we would have been as successful. I think the cross-cutting of and making each team responsible for an entire epic, soup to nuts, no matter how many LRUs it touched, no matter how many different programming languages they had to know in order to do that, has made us successful and has really broadened the scope of what our teams do. In addition, each of our teams now runs safety of flight tests. And that means that people who were adamant that I am not going to run a test, I am a coder and I am not running this test, did it anyway. And it really broadened their minds and gives them a little bit of a break. And also, if you've ever had a dedicated, I worked on a dedicated test team. That was my first job in the Air Force. And after a few years of doing that, you want to just, you look at another test report and you just want to open a vein. I mean, it was bad. And so they, by rotating it like this, you kind of eliminate that burnout thing. Alan's got his hand up. I can see it. Hi, Alan.
Hi, Dave. Thank you. Hey, the most fascinating thing here you said for me was something that sort of was just a given. This direct connection to the pilots.
Yes.
And most of the projects I've consulted on in DoD, there isn't that direct connection. Did that already exist, or did you have to do something miraculous to get that connection?
So
did you understand the question?
Yeah. So early on in the old waterfall technique, they found out that they were finding stuff very late in delivery that could have been corrected earlier had they known the pilots wanted it differently. So they actually implemented a form of this in the old days. So it wasn't something that the pilots were unaware of. However, it wasn't consistent. They would create a meeting based upon when the pilots were going to be in the area for something else. And then they would invite them in and everybody would scramble. And there were these things called candidate teams back in the day that, like I said, they weren't a real team. It was just a group of people that were interested in the same candidate working together to try to do it. And so it was effective, but it wasn't anywhere nearly as effective as it is now. One of the things that the lessons learned, we would take the pilots up to the test stand in the old days, and it was the system engineer that sat with them, system design engineer, I should say, software design engineer, that would sit with them, and they would ask a question. And it was a question the coder would have known, or maybe the tester would have known, but this guy didn't know. And so he had to say, I'll find out, I'll get back to you after lunch, or I'll find out and I'll get back to you tomorrow. If that person that he was going to find out from was out of town or had moved on, he couldn't find out right away. It was kind of a hard thing. Now the whole team goes up to the test stand, the whole Agile team goes up to the test stand with the pilot, watches it, gets feedback, and when they ask a question, the person who knows is right there, and they give the answer. It's been, the pilots have loved that part. So yes, it was kind of there, but I think it has really grown a lot since then. Now that they see
you had the seeds. You had the seeds, you watered them, you made them grow into a giant forest of cool. All right, got it.
So David, Bartu's questions were about what quantitative analysis you perform on the A-10, and do you use any process performance models?
So that's a fantastic question. I have been attempting to get a good process performance model working for quite some time. The answer is on occasion, I do process performance models. What I'm looking at now is a lot of our folks are moving to more of a Kanban type of approach where you're looking at trying to get the same size chunks of cards through the Kanban and out on a regular basis with high quality. And I'm looking at the duration of each user story as it goes through the system and the duration that it takes from the time they pull it out of new until the time it gets done. Sorry about that. And some teams, it turns out it's so far it looks like it's team-based, because some teams are extremely narrow in their variation on that, and other teams it is all over the place. And I'm trying to find out of those teams that are doing it, what are the model tweaks that you can make, the data inputs that can narrow that down and get that. Is it just experience of the team? Is it just the fact they're working on an epic that everybody on the team has experience with? Or is it something different? Is there a process change that can happen to make teams more consistent? That's what I'm looking at right now in terms of that kind of data analysis. The other kind of data analysis I've done is to see what are we giving the pilots in terms of deliverables? Are we consistent in providing them a certain number of, and I'm going to be honest, I'm using lines of code as my counting mechanism. Are we giving them a certain number of lines of code each update? I know I can measure it by epic, but epics are so volatile in terms of size and complexity that that's not really a good indicator. And right now, what I'm finding is there is some variability release to release on the lines of code that we're sending out the door, and I haven't quite figured out what all of the parameters are on that yet. But one of them is complexity of the epic. So one of the things I did look at that you might be interested in is I looked at one of the things that drives me crazy about Agile is there are no actuals. You can do story points. There's no actual story points because you can't measure actual story points. So there are ways people backfire that information. But I started looking at epics. So this epic was a 2. How long did it take? You know, how much effort was put into it? Did it make its intended PI, or did it slip to the next one? This was a 5, same questions. This was an 8, same questions. And what I found is we were absolutely horrible about meeting the number of sprints that we thought we were going to meet, but we were fantastically accurate in predicting the complexity of the epic. So an epic of 1 or 2 complexity, let's call it. They call it job size. It's supposed to be sprints and it's not. But 1 or 2 will always meet, like I think it was something to the effect of 92% or something like that. Almost always meet the PI in which it was planned to deliver. Which is a big deal. The ones that didn't had some kind of blocking condition for them. 3s were a little less. They were like 88%. So still pretty high. Once you get into 5s and above, you start seeing less likelihood of making it into the program increment that they were planned for. And you get to an 8, it almost never makes it. And you get to a 13, forget it. It's just they have no idea when that one's going to be delivered. So they are pretty good at not at establishing the number of sprints it's going to take, but they're pretty good at using those numbers to identify the complexity. So they're all sorts of things, fun things I'm doing. So.
Interesting. Yeah, very interesting that about these different approaches of treating these agile constructs in a quantitative way and doing some real thorough analysis that adds value. So that's really interesting to me. Thank you. You made a comment as part of that, and it had to do with quality, I think. There was one question in the chat about how do you prevent people from cutting corners so that the documentation is accurate?
That is a fantastic question. Really the only, and you're talking in terms of documenting the change that was made, I assume, in terms of the engineering documentation.
I don't have the full context, but I assume it's the engineering documentation and the supporting documentation that adds value to, you know, the overall A-10 program, whatever that may be.
The way you do that is through, unfortunately, through a multitude of different reviews. So as they are going along, each story that they have that adds to, by the way, the system engineers, the documentation folks that actually update the system level documentation, they have stories assigned that they pull to go work things as well. And as they complete each story, there is a definition of done for that story. The story. But by the time they get to approval, not only has it got to be peer reviewed by our team, it has to be peer reviewed by members of other teams, and it has to go through a quick review by the program office and the pilots. It doesn't slow them down much. I really worried early on that this would really slow down the process. It doesn't seem to slow them down much, which tells me that the external peer reviewers are kind of pencil whipping it. But it does give them a certain level of check to make sure that they got things right. The other thing is that the engineers that actually implemented the stuff will be the reviewers of the documentation on the internal team, and they find a lot of things that say, hey, wait a minute, that didn't get documented correctly, or I wouldn't document that particular way. Let's try this way. And it seems to work.
Thanks so much, and best wishes to you.
Thank
Excellent.
you. Thanks for having me on.
All right, bye-bye.
Bye-bye.
Talk to y'all soon. Bye.